Hi everyone, MindFlareRetro here. So you dug your old Commodore 64 out from storage and you're eager to fire it up, but you haven't powered it on just yet because you heard that the old C64 brick or wedge power supplies, these are the brick ones, slowly go bad and can severely damage your precious retro computer. Well, you are correct to be leery. Over time, even if unused and stored well, the components within the original Commodore 64 power supply units, or PSUs, can fail, causing a deadly overvoltage and fry one or more of the aged, delicate chips on the motherboard. Failed power supplies are probably the greatest cause of C64 deaths these days. If you want to learn more about this, I highly recommend reading the post titled "The Commodore Brick of Death" by forum member 𝐺-𝐹𝑢𝑛𝑘 on lemon64.com. I'll post a link down below. Anyway, what do you do about this? Well, there are a few options. Option one is to ignore the inevitable and go right ahead using the old power supply and hoping for the best. This is a bad Russian roulette option in my opinion, because it's not a matter of if the old power supply will fail, it's a matter of when will it fail, and it will fail. Option two is to buy or build your own replacement power supply. There are several options out there on forums, eBay, and directly from people in the know, like Commodore computer repair guru Ray Carlson. These ready-made options can be a bit pricey, but in the case of Mr. Carlson, you get what you pay for. High quality and trusted designs and excellent build quality. Alternatively, you can build your own C64 PSU based on contemporary designs and using modern components. For example, Sven Petersen in Germany has designed an excellent replacement power supply for use in the 230 volt regions of the world that you can build yourself. But option 3 is what the video is all about today. Although acquiring a brand new power supply is an excellent decision, another solution or workaround is to have some sort of protection between the old Commodore brick or wedge of death and your precious C64. And this is where a C64 saver comes into play. A C64 saver is an overvoltage protection device that monitors the 5 volt DC output of the power supply and will cut the power if the output voltage rises to or exceeds a critical voltage above 5 volts, which, as we all know, can damage a natively unprotected Commodore 64. Again, there are several of these available on eBay from retro computer forums and even Ray Carlson directly. To my knowledge, once again, Ray Carlson was the first person to devise a C64 saver device that he still sells, but also has posted the circuit design for anyone else to build their own if they wish to. His first saver design was based on a relay that would switch open when the voltage went too high, thus cutting off the overvoltage. Later designs from Ray and from others evolved into a fully solid-state component design using a MOSFET instead of a relay. This not only allowed for a smaller form factor, but also for a much faster and safer off switch when overvoltage had to be cut. One saver design was particularly impressive. The C64 Saver version 1.2, created by BWAC in Norway, is an overvoltage protection circuit small enough to fit on a tiny circuit board about the size of a fingernail, and was able to actually mount inside the casing of a standard 7-pin DIN plug. There's actually a circuit board in there. This made for the sleekest, most elegant design I've seen to date. And I was fortunate enough to buy one of these from BWAC about 3 years ago, and I've used it ever since. Now, unfortunately, BWAC had to stop making these because of the super time-consuming effort required to assemble and test these teensy savers. But, being a selfless supporter of the retro computer community, BWAC decided to redesign his C64 saver, this time based on a small footprint standard PCB variant using easy-to-assemble components. His intention was to allow the retro computer community to build their own C64 savers as easily as possible. And this is what we will be doing today. making this. This is a C64 Saver version 2.4. And thanks to my friends at PCBWay who are sponsoring this video, I will walk you through the whole PCB ordering process, the parts ordering process, and ultimately the build process. And it's all a lot easier than you might think. So, enough of me blathering on. Let's get started. In step 1, we're going to acquire the PCB design files. And to do that, we're going to navigate to github.com and BWAC's account there. If you've never heard of GitHub, it can best be described as a web or cloud-based project management and code version tracking system for developers. Here we can see all of BWAC's projects, and the one in particular that we're interested in is this, the C64 Saver. Here we can see all of the project files, including descriptions, notes, and various other supporting documents. Now, if we wanted to, we could download all of the design files by clicking the green button here, but we're only interested in one particular version, so we're going to click on the releases link right here, which takes us to another page listing all the particular version releases. And we are interested in C64 Saver version 2.4, and within that, we are only after the Gerber files. These are the PCB design files that we need to upload to PCBWay. Now we just need to download the correct file, and that's this one, c64saver24gerber.zip. And just save that to a convenient location on your computer. And now that we have our Gerber zip file, we can move on to the next step. And yes, I am happy to announce this video is sponsored by PCBWay. PCBWay, PCB prototypes the easy way. Wow, very exciting stuff. My first sponsored video. Thank you very much, PCBWay, for your support. And back in our browser again, we're going to navigate to PCBWay.com. If you've never been to a PCB manufacturer's website before, things might look a little bit overwhelming, but once you take a quick look around, you can understand what's going on, and it's really quite simple. Basically, you're provided a lot of little sections of information, including services offered both in-house and third-party, current promotions and special offers, prototype PCB options and requirements, and even the ability to dive right in and do an instant quote. Now I'm going to click on the PCB Instant Quote menu option, which brings us to the standard PCB quoting page. PCBWay's standard PCB quoting tool provides us with a generous number of options, most of which are pre-selected for us, although we do need to know some specific information, in particular the length and width of the project PCB we're working on. In the event we don't know that critical piece of information, PCBWay has provided a new tool, Quick Order PCB Quoting. And all we have to do is upload our Gerber files, whether we have our own or have downloaded them from someone else. In our particular case, all we need to do is select and upload the Gerber.zip file we acquired from BWAC's GitHub. Within seconds of uploading, the Gerber files are read, and pertinent information, such as the dimensions of our PCB, are entered into our quote. Now, how about a sneak peek of what this thing's going to look like? Click on Online Gerber Viewer, which takes us to this page, and we're presented with an instant art rendering of our PCB and what it will look like after manufacture. This, of course, is the top side, but we can also click on Bottom and see the bottom side. And now back we go to the PCB ordering page. I've taken the liberty of logging in with my existing PCBWay account. I've actually been a PCBWay customer for the last couple of years, using their services several times in the past. So I was genuinely surprised and very appreciative of PCBWay offering to sponsor this video. Ultimately, my goal for this video is to make this project as simple as possible, allowing anyone to be able to order their own PCBs and create their own C64 Saver. Having said that, we are not going to get into all the different options that are available when ordering PCBs. We're going to stick with all the default options provided to us on the ordering page. However, we can look at solder mask color options: green, red, yellow, blue, white, or black. Selecting any of these color options does not affect the cost of the PCBs. However, if you wanted to go with purple, matte black, matte green, or none, then there is a little bit of an extra cost at this time. Do keep in mind to select the correct silkscreen color appropriate for the solder mask color that you've selected. For example, I want to make sure I select white silkscreen color for my blue PCB so that I can read any text or component footprint locations on the circuit board. On the right hand side of the order page, we have the pricing and shipping options. There are a few changes we have to make here. First of all, I am not located in the United States. I'm located in Canada. And I want to be frugal when ordering my PCBs. So I'm going to change the shipping from DHL to ePacket. And that makes a significant difference in the shipping costs. I typically receive my orders in about 10 days using ePacket. That shipping method is fine for my purposes, but feel free to select your own shipping method depending on how quickly you want your PCBs. So as it stands now, ignoring that $1 discount that's showing in the bottom right, we are getting 5 PCBs manufactured and shipped to us for $11 US. However, we can get more bang for our buck. If I click the quantity field, I am now given the option to select a different number of pieces I want to receive in my order. I'm going to go ahead and select a quantity of 10. And if we look at our recalculated pricing, we see that we're paying the same for the PCBs, only the shipping has gone up by $1 because of the weight. Can we do even better? Let's try 15 pieces. Okay, this time we're seeing a significant bump up in the price, so I think we should go back to 10 pieces. Only because this is a prototype and 10 pieces is more than enough for what we need to do. So for about $1.20 a board, we're getting 10 PCBs manufactured and shipped to us for $12. That's a pretty good deal if you ask me. Now you might have noticed that there's a $1 discount indicated in my pricing quote. This is because, as I mentioned earlier, I have been a PCBWay customer for several years. And as with any PCBWay customer, I've accumulated rewards points with every purchase. And to be perfectly honest, this is why I most often selected PCBWay years ago for my own personal projects, long before any chit-chat about sponsored videos. And as like any consumer, I appreciate being rewarded for my customer loyalty. Moving along, I think it's safe to say we're satisfied with our order setup and it's time to add it to the cart. Now, if you haven't already done so, you will need to sign into your existing PCBWay account to continue, or if you're new to PCBWay, you'll need to create a new account. And as a new PCBWay customer, you are entitled to a $5 welcome bonus, so that's $5 off of your first PCB order. Now that we've signed into our PCBWay account, we can see in our shopping cart that our order is officially in the hands of PCBWay. However, we can't actually pay for it yet. You'll notice that the order status indicates subject to audit. At this point, the Gerber files that you uploaded are being checked by a PCBWay PCB specialist to make sure that everything is in order and there won't be any kind of manufacturing problems. In the event of any concerns, they will contact you by email and you can work with them to resolve any potential problems. According to information on the PCBWay website, it can take upwards of an hour to audit your PCB design. And of course, you will be notified once the audit is complete. If you are still logged into your PCBWay account, you will see a message center pop up once your audit is complete. So now under your account, be sure to click on the Orders List menu option. This will list all your orders and whatever particular stage of processing the orders are at. In our case, we have nothing under review. That's because our order just passed its audit. And our order is now awaiting payment. So now if we scroll down a bit, we can see the basic details of our order. We can confirm that everything is correct, and when we're ready, we can click on Proceed to Checkout. Next, we need to confirm our shipping details. Always be sure to double check your shipping address, and be sure to select the shipping method that you want. If you remember when we did our quote, we had selected ePacket because that was cheapest, and we need to officially select that shipping method here. Finally, if we scroll down a bit more, we need to select our payment method. I always prefer to pay with PayPal whenever possible, and PCBWay allows for PayPal payments, so perfect. And if you had any discount coupons or codes to apply, you would do that here. Finally, we've reached the point to confirm our order and pay. Everything looks good, and all we need to do is click the Confirm and Pay button. Our order is now being processed by PCBWay. Okay, it's about a day and a half later, and if we log into our PCBWay account, we can check in on the fabrication process of our order. The handy progress bar indicates that our order is 92% complete. And if we click on the technological process button, we get a very detailed account of where our PCB order is within the fabrication process. And with only a little more patience, our order will be completed, it will be packaged, and delivered to us. And while we wait for our PCBs to arrive, it's the perfect time to move on to the next step. It's now time to order our parts, but which components do we actually need? At the time I was recording this part of the video, there wasn't an up-to-date BOM or bill of materials available for version 2.4 of the C64 Saver. There is a BOM Excel file included in the full project download from BWAC's GitHub. However, this BOM is for version 2.3 of the C64 Saver, and version 2.4 does have some component differences. However, this isn't too big of a deal because I do have KiCad installed, so I can just open up the schematic file and take note of all of the components required. What I ended up doing was creating a document organized to my mind anyway, all the components required, even color coding the resistor values. I also added links to the sourced parts. I really want to do this project properly, so I've decided to use only name brand parts from reputable electronics parts distributors. I am located in Canada, so DigiKey and Arrow Electronics are the least expensive suppliers when you include shipping. And yes, I will include a link to this document in the description below. Ultimately, I did elect to go with Arrow Electronics for this components order, primarily because they had all the components I wanted in stock, and in the case of the resistors, and this might sound a bit OCD, I wanted the resistors to be from the same manufacturer and from the same product series from within their product catalog. And for less than $24 Canadian, I was able to purchase enough PCB components to make 10 C64 Savers. Now that our components are finally on order, I think we should review what we've done so far. Acquired the Gerber files, check. Ordered PCBs, check. Ordered parts, check. And while we wait for our PCBs and parts to arrive, I think it would be great to hear from the man himself, BWAC, designer of the C64 Saver.
And hello, this is BWAC, and thank you, Mark, for putting me in your video and talking about my design. So this is my design. It's the C64 Saver 2, as you may know. The power comes in here. It's very basic stuff. It's an overvoltage protection, which is done in this circuit, which is a TL431, and then you have a power transistor, which is breaking the path between 5 volt in and 5 volt out. So, and that's basically it. So I based it on Ray Carson's circuit, and he used two NPN transistors, I think, and I think he uses, it's 4 years ago, so he based his design around the base emitter voltage. I don't know if you understand what that is, but it's when temperature changes, the base emitter voltage changes a lot, and I didn't like that, so therefore I thought, okay, TL431, which acts like a perfect diode. The diode is like, turns on very sharply, but this one is really sharp, so, and it doesn't drift with temperature, and it's used in power supplies. It's like 0.3 euros for a piece for 10, so why not, I thought. And the difference in this design and my earlier design is that I have protected with the Zener diodes, I protected the devices on the board. So, and it's really easy to build. If you want to build it yourself, just add the resistors all through all components. The only SMD is this power transistor, but it's also very easy to solder up. This is the schematic for the C64 Saver 2. We have power coming in on the left and exit on the right. Then you have the sensing circuit, and then you have the switching circuit. over here. Here is the sensing part, TL431. So if the sense input there goes about over 2.5 volts, it will turn on, pull this down to 2 volts, not to 0 because it needs power to drive itself. 2 volts is not enough, so divide it a bit more, so the NMOS will then turn off. This point is now free and is pulled up to 5 volts, and then this one will also have no gate source voltage, and then there will be no current through it either, so it cuts. That's basically it. So thank you, Mark. Back to you.
Thanks very much, BWAC. If you are into retro computing and related hobby electronics and you haven't heard of BWAC, I highly recommend that you visit and subscribe to his YouTube channel. BWAC is always taking on new and interesting projects and has always been a selfless contributor to the retro computer community. Even PCBWay has taken notice of BWAC's work and are sponsoring his latest project, the C64 KU14194 motherboard replica project. Again, check out BWAC's YouTube channel to see all of that incredible work. And back at my workbench, both components and PCBs have arrived. Now, BWAC designed the PCB to fit perfectly inside a very specific enclosure, the Hammond 1551G, which are these little guys. And I did manage to purchase these, along with this variant, for only a few dollars from a local electronics supply store. I have to say, even though it's a little bit more expensive to purchase components from a reputable supplier, you are guaranteed to get genuine components, and everything is always packed very well. And saving the best till last, here are our completed PCBs, thanks to PCBWay. Now, because this PCB order was sponsored and paid for by PCBWay, I did opt for a panelized version as well as gold immersion, so all the contacts are gold plated. This is absolutely not necessary for this PCB design, but I wanted to see what the quality would be like, and it's quite excellent. I have checked all the components received, and I'm happy to report that everything is in order. However, a lot of these things look alike, so I think I would like to organize this a little bit better. Fast forward a couple of minutes and I have everything organized into individual compartments within this case. As mentioned by BWAC earlier, this MOSFET is the only SMD component used in this saver design. This component package is called a D-Pack or TO252. It has 3 SMD contacts that need to be soldered to the surface of the PCB. If we take a look at the underside of this component, we see that the drain connection actually has a fairly large surface area. If we look at the PCBs themselves, we can see that the D-Pack component position has a very large solder pad. I've never soldered one of these components before, and I'm assuming that we need to flow a little extra solder underneath to assist with heat sinking. These panelized PCBs are V-scored, meaning the border around each individual PCB was lightly milled during fabrication, allowing us to break them apart easily. I am under no obligation to say only nice things about the workmanship here, but I do have to say that these PCBs are of excellent quality. Our little D-Pack MOSFET needs to be installed here, and once again, I'm assuming I need to flow a little extra solder underneath that contact onto the pad below. However, and I don't mean to cause any unnecessary disappointment, but I am going to split this video into 2 parts. I haven't posted a video in quite a while, unfortunately, and there is quite a bit of channel administration to take care of. Rest assured, part 2 will be released in a timely manner, and we will complete the assembly and build of our awesome C64 Saver version 2.4. As I said, I haven't uploaded a video in a while, and I apologize for that. I do appreciate everyone's patronage as a channel subscriber, and especially as a Patreon subscriber. And speaking of patrons, I've had several new Patreon supporters since my last video was posted. In particular, 2 new Tier 3, that's the High 5 tier supporters, have joined. So, as you know, when you join the High 5 tier, you get an on-screen high five. So thanks very much to James Ezel, and Troy for being my latest Tier 3 supporters. High five to you, James. And high five to you, Troy. Thank you both very much for your generous support. In other news, back on September 10th, 2019, this channel hit a new milestone of 10,000 subscribers. I never would have thought this was ever possible, but here we are. And I owe it all to the support of the retro computer community here on YouTube and also on Twitter. So, what else is new? Well, many months ago, I started a Discord server for local retro computer enthusiasts to chat about all things retro computer and newer computer related. I think it's a good time to shake things up a bit and invite other not-so-local people to join in the conversation there. We have about 80-plus members at the moment, and most of those people are located in and around my area of Canada. I'm hoping we can inject some new voices from other regions of the world, so if you're interested in checking out the MindFlareRetro Discord, I will post an invite link below. Something else new is the introduction of the MindFlareRetro Teespring store. If you check out the merch shelf below, you'll see some examples of retro computer related t-shirt designs. In fact, I'm wearing one of them right now. I will also post a link to the shop in the description below, and I will also include a coupon code to save you 10% at checkout, so be sure to look for it in the description. Finally, I wanted to extend a huge thanks to PCBWay, and in particular my friend there, Elaine, who has been exceedingly patient with me, as I should have had this video out a long time ago. If you follow me and other retro computerists on Twitter and here on YouTube, you will know that PCBWay has been very supportive of the retro computer community, especially over the past year. And I wanted to thank them very much for their generosity in sponsoring this video and also for sponsoring numerous other retro computer projects around the world. Be sure to see the link below and visit PCBWay for your upcoming PCB manufacturing projects. You won't be sorry. Okay, I have to call it there for part 1. I do realize that this can be a bit of a dry topic at times, but remember, my intention here is to make a how-to video, how to make your own C64 saver from scratch. I'm sure there are a lot of retro computer enthusiasts out there who have never ordered printed circuit boards before, so I wanted to show them how easy it is. Part 2 will cover the construction of the C64 saver. And in the end, someone might build their own C64 saver who wouldn't have otherwise. In which case, my mission is complete. I hope you enjoyed this video. Don't forget to like or dislike, comment, and share. Okay, that's it. That's all for now. I am out of here, and I'll see you soon for part 2. And maybe we'll do a giveaway at the end of that one. Thanks for watching, thanks for your time, and see you again soon.
Ha ha ha.